Let us study resistors in series. Now if you look at the figure, we see that the ends of the three resistors are connected so that they follow one after the other. Such an arrangement is called as resistors in series. Now in this case, current will be same, current will be flowing is same, but the voltage across each resistors will be different. Let V1, V2 and V3 be the voltages across resistors R1, resistor R2 and resistor R3. So let the voltage across the three resistors, across them be V1, V2 and V3, right? Now total voltage will be equal to V is equal to V1 plus V2 plus V3. Let this be equation number 1. That if RS is the effective resistance, and what is RS? RS denotes that, S denotes us that it is the resistance are connected in series. Now if RS, what will be S? S for series. S for series. If RS is the effective, resistance between points C and D, effective resistance between which two points? Points C and D, between points C and D. Then according to Ohm's law, we know Ohm's law, then according to Ohm's law, and what is Ohm's law? V is equal to IR, but here S for series resistance, so we will take I is equal to IRS. So for each resistance now we are going to calculate. So V1 will be is equal to I into, what is this? Resistance R1. V2 is equal to I into R2 and V3 is equal to I into R3. Okay, now we are going to substitute all these values in equation number 1. So let's write substituting all these in equation 1. Substituting in equation 1. And what is equation 1? V is equal to V1 plus V2 plus V3. Therefore, what is V? V is I into RS, which is equal to, what is V1? V1 is I into R1 plus, what is V2? I into R2 plus, what is V3? I into R3, right? Okay. Therefore, now see, if you remove common from here, if you remove common I from here, so this I and this I goes. So what we get is RS is equal to R1 plus R2 plus R3. Okay. Now if n number of resistors are connected, then in this case what will happen? If n number of resistors are connected, if n resistors are connected, if n resistors are connected in series, then what will be the effective resistance? RS is equal to R1 plus R2 plus R3 plus nth value plus dash 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 plus Rn. This gives me the effective resistance of the resistors which are connected at the nth value. Let us study resistors in parallel. When do we say that the resistors are connected in parallel? When their ends are connected to both the sides. When their ends are connected to both the sides as shown in the figure. You can see in the figure the ends are connected to both the sides. Now here we have got resistor R1, resistor R2 and resistor R3. All three resistors are connected in parallel. Now here the current will differ. I1 will flow through this, I2 will flow through this and I3 will be flowing through resistors R3. So let I1 be the current flowing through R1, I2 be the current flowing through R2 and I3 be the current flowing through R3. Okay, so let's write, let I1, I2 and I3 be the current flowing through which resistors? Resistor R1, R2 and R3 respectively, through R1, R2 and R3 respectively. Now here the potential difference, that is the voltage V across point C and D will be V, right? So what will be the total current flowing through that circuit? So we will write total current flowing through the circuit will be I1 plus I2 plus I3. The total current flowing through the circuit what it will be? I is equal to I1 plus I2 plus I3 dash dash. Let this be equation number 1. Now let RP. Now what does P denote over here? P denotes here for parallel. P for parallel. Let this be the effective resistance between point C and D. Be the effective resistance between points C and D. Now according to Ohm's law, according to Ohm's law, what we have according to Ohm's law? I is equal to V upon R. I is equal to V upon R. But what we are using here? We are using here RP to denote that it is a parallel effective resistance. Similarly, what will be I1, I2 and I3? Let's write. Similarly, I1 is equal to potential difference, that is the voltage will be same, V upon R1. I2 will be is equal to V upon R2 and I3 will be V upon R3. Now we will take all these values and substitute these values in equation 1. Substituting in equation 1. Now what do we get when we substitute this in equation 1? Let's see what is equation 1. I. What is that? V upon Rp. So let's write V upon Rp is equal. What is I1? V upon R1. What is I2? Plus V upon R2. Plus what is I3? V upon R3. Okay. Now if you remove V common over here, this V gets cancelled with this V. So what we get? Therefore 1 upon Rp is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. Now, if n resistors are connected in parallel, if n resistors are connected in parallel, then what will be the effective resistance which we are going to get? 1 upon Rp is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3 plus dash dash up to the nth value of that resistance plus 1 upon Rn. This gives me the effective resistance of the nth resistor.